Good morning, students. Today we are going to see the architecture of 8086. Right. So here we are having now we already discussed about that 8085. Now we are going to see some advanced processor at 8086. Right. That advanced processor 8086. We are having now that one 8086. This is advanced processor. Right. So this 8085 is actually we are having an 8-bit. The processor is 8-bit processor. So the data is 8-bit. Then if you want to have that 16-bit, then we have to do two 8-bit process. Now that 8086 is 16-bit processor. So the data is 16-bit. 16-bit data. Okay, that 16-bit processor. The 8086 is a 16-bit processor, and this 8086 is developed by Intel Corporation in 1970. So that is a basic processor. Nowadays we are having i7, i5, i7. Everything is advanced one. So we are having the basic is from the 8086. Right. Now in that 8086, then what are the components are available, right? So yeah, whatever the processor it may be, we are having arithmetic logic unit, control unit, and some set of register, right? Arithmetic logic unit, control unit, some set of register, ALU, CU, control unit, and some set of registers. So this is a basic need, right? Now here we see that one. Here we are having now that arithmetic logic unit. So this is the ALU, right? So ALU is arithmetic logic unit. Arithmetic logic unit, we need to have two operand, right? So here we are having operand 1. Here we are having operand 2. Two operand, right? So then it will do that operation. Then on that one, then we are having the arithmetic logic operation. It will do now. Then as like and subtract, multiply. Then we can do that one, right? Now here we are having now the control unit, right? So control unit is used for controlling the data flow, controlling the data flow, and with clock, then it will control the data flow. So that is called CU, control unit, right? Now here we are having another one important concept is here we are having a pre-batch queue. So what it is actually, we are having 6 byte. 6 byte is here, right? So actually we are having your memory. So this is we are having a processor. In that processor we are having control unit, arithmetic logic unit, and some set of registers, some set of register, and along with we are having one instruction queue. We call it as actually this is a instruction queue. Instruction queue. So instruction queue is our instruction is going to be queued with three instructions continuous, right? Now you see this one, this processor is externally connected with that memory or IO device, right? The memory is we are having now that I already told you that one, this is a byte addressable memory, right? So that is we are having now that memory is there, byte addressable memory, right? Here we are having now the byte addressable memory. This memory in that case of 8086 is divided into four segments. That is we are having now that core segment, then we are having data segment, then we are having now that stack segments, and then we are having now that extra segments. So we are having now core segment. Core segment is CES, then data segment, then we are having stack segment, and extra segments. We are having now some extra segments. So it your memory is going to be split into four components. The core segment, the core segment is used for storing your programs, right? So we are having instruction by instruction we are loading, right? So the hexadecimal instruction is going to be loaded, right? As in the 8085 we are having the hexadecimal value, right? 3E000. Then we are having now 32, then we are having 0092. Like we are giving now, this is actually opcode, then followed by data, opcode followed by the data we are having now. So that is we are having, this is a sequence of opcode, then with the data is a program, right? So the program is in code segment. Some data if you are storing, right? So in that 9000 we are having some data as like here we can store some data. Whatever the data you want to process, the data is going to be stored in data segment. Then the stack segment is used for, suppose we are calling that if you are doing that interrupt routine or function call, then at that time it will use the stack segment for storing and retrieving that information. So for that we are having now the component as stack segment. Next one is we are having extra segment is used by the operating system. Then there is some intermediate value we are going to intermediate data we are going to store in the extra segment part. Right. Now here you see this one. Your address bus is 20 bit. In that case of 8086, the address bus is 20 bits. 20 bits address bus, and the data bus is 16 bit data. Right. So that is we are having in the multiplex only. Right. So the data bus address bus is going to be connect with. So we are having this address. So address buses we are having 20 bits. 20 bits is here we are having start with 0000 5 zeros. Then at the end we are having now 5 FF. In microprocessor we are having now, that is we are having only 4 hexadecimal number, right? 4 hexadecimal 8000. If you are putting now that 8000 or 8000 or 7FF, the previous one is 7FF, right? Then afterwards then we are having 8001. So this is we are having address in the 8085, right? Don't confuse with that one. Here we are having 5. So this is a 20 bit, this is 16 bit, so 4 bit extra. So we are having now that memory is yeah, big size as compared with that 8085, right? Now this is a program. Now actually what it will do now, then it will take the first 3 instructions. So the first 3 instruction with opcode or something, this is going to be loaded in here, right? First instruction, second instruction, and third instruction is placed on instruction queue. So why we need to have that place the code in the instruction queue is, we are getting that we are fetching the data from the instruction queue is very fast as compared with from memory. So that from memory it will take now, and at the same time it will fetch the instruction for processing. So in that queue we are having, we are placing that 3 consecutive instruction is placed on that instruction queue. Then whenever it want to execute, then it will take that instruction from the queue. Then if the instruction is the first instruction is going to be executed, or we are going to fetch and it will place in the control unit, it is going to be executed. So we are having now in that pipeline we are having now fetching and decoding and execution. So these are the 3 phases of one instruction. Fetching the instruction is, we are fetching that instruction from memory, right? So that is we are having fetching this instruction from the queue. So first instruction is fetched into the control unit, right? Now the control unit will do now the decode the instruction and then execute the instruction. Decoding that instruction means it will give the sequence of operation for that particular instruction execution. Then during the this sequence of operation is going to be executed, then that is called execution. So one instruction is going to be fetch, decode and execute, that is in that queue, right? So that one as here first instruction is going to be fetched. Then at that time this instruction is going to be moved to that in that queue. Then that last part is vacant, then it will take the next instruction from the memory, right? So that is transfer at the same time of that first instruction is executing. So both can be done in the pipeline and in parallel, right? At the one clock it is executing one instruction, at the same time it will it will get another instruction and it will place the instruction into the queue, right? So that is we are having now a friend, this is friend, this is rear. From the rear we are taking now the instruction for execution, right? So every instruction is going to be moved to queue, and from that queue it will execute that instruction. So that is the queue is going to be used for high performance fast execution of the instruction. For that we are having now the queue. So or otherwise we can call it as actually this instruction pipeline, instruction queue we are having now, right? Now here that here control unit is there. In that particular 8086 we are having two major parts. This is the execution unit, then this one is first interface unit, right? First interface unit is here for addressing here, and also we will see that one, this code segment is a register, this code segment is a register, this is 16-bit register, 16-bit register, right? Now the 16-bit register is this is a code segment. Here 16-bit register is, we can have now the 16-bit data is storing. So first 4 digit is going to be stored in code segment, right? So if suppose the code segment is starting from 4 zeros, so in that code segment part the starting address of the code segment, right? So 4 zeros are there, right? Then how can you get that 50 is, this 40 is going to be multiplied by 10. So multiplied by 10 is, here the hexadecimal is multiplied by 16. So multiplied by 16, then we are getting now that another 0, the last end 0. So the 50 is the 20 bit. Now the 20 bit address bus here, right? So this is a 16 bit data. The 16 bit data is multiplied by 10, and also we can get some offset. Offset is here in that core segment. What is the offset of the current data? So this is offset. This is the core segment. Then core segment is added with that offset the current location of the core segment. Similarly, in the data also we are having now the data part, and we are having the offset. Then it will take one particular location. This offset is added, right? So current this is the current position. This is the starting address of the data segment part. Then from the starting, how long the distance of the current data. So that is we are having now that offset. Similarly, from the starting address of core segment, how long the current in section. So that is we are having now that offset, right? So how do you call the effective addresses? This is a physical address, right? So four zeros are physical address. First four zeros are physical address. This is there in that core segment. Then we are multiplying that core segment with 10. 10 is we are having the in 16. So it will convert it into 20 bit with added with the last 4 digit. Then now we are adding the offset. Offset is how long the distance. So we are getting now the effective address. The effective address is going to be placed on that address bus. Then we are having now that corresponding address, effective address, right? So this is a physical address. Multiply by 10, we are making this is 20, and we are adding the offset. We are getting now the corresponding location of the current intersection. So this intersection is going to be fetch, right? Here we are having the core segment starting address, stack segment starting address, data segment starting address, and extra segment starting address is going to be stored in that register. So we are partitioning that memory, and the starting address of core segment, stack segment, then we are having data segment, and extra segment is stored in the registers. So segment register is there. Then followed by we are having the instruction pointer. Instruction pointer is as like a program counter in 8085. This is a instruction pointer. So instruction pointer is showing the current instruction is going to be fetched from the instruction. So this is the instruction pointer. The instruction pointer also 16 bit multiplied by 10. It is converted into 20 bit, and then we are having some offset of your program part. So this is for example here it's a starting address is 8000. Now we are having that one instruction is 8001C. Now we are getting now the offset is 1C. So 8000 is added with 1C. We are getting now the corresponding location. In that way, we are having now the instruction pointer is having that one. Then it will add with that code segment. So code segment plus instruction pointer. We are getting now the corresponding address. Right. Here we are having the general purpose registers are ABCD. ABCD is general purpose register. This is a 16 bit. So the 16 bit is split into two parts, lower and higher. Lower 8 bit, higher 8 bit. So AH and AL, PH and PL. So that combined together as 16 is called AX. AX is 16 bit register. Here the lower is 8 bit AL, the higher is 8 bit AH. Here we are having that BX is a 16 bit register. Then the PH and BL is the part of that lower part and higher part. Similarly, C is used for lower part and higher part. D, right? So D also. Here we are having now these are all the general purpose register, right? On that case of our 8085, we are having accumulator. The accumulator is going to use for getting the result, the effective result, right? Here are not like that. If you want to have that execute that one, then we can execute any one of that register. So here we can get now AX equal to AX plus BX, AX plus BX, right? Then we are having BX equal to BX plus CX. This is also possible, right? So we can have now, right? Next we are having now the another points are stack pointer, base pointer, source indexing, and destination indexing. So these are all the special purpose registers: stack pointer, base pointer, stack in source indexing, and destination. What do you mean by that one? As stack pointer is here we are having stack. Now the top of the stack is called stack pointer. So in the from the stack starting address of stack, then where we are having now the current place of the top of the stack. So that is there in the stack pointer register. Here the base pointer is here if you are having now that one array of data. In that array of data we are having now that indexing. So the base pointer is showing the index. So this is starting address of that array. Then from that base pointer, if you are adding now the effective address of that corresponding location. So that is base pointer. Next one is source indexing and destination indexing. Suppose you want to copy a block of memory from one location to another location, right? Now we are having, this is the starting address of that source, and this is starting address of destination. Then it will use one source index, and here it will use destination index. So here we are taking the data from source index and destination index. We are incrementing source index and destination index. Then we will go for the next data and we are placing now. So the source index and destination index is used for indexing purpose. We can get it now. So we can copy the data using the source indexing and destination indexing. So in that case of 8086, these are all the processor, and also we are having a flag register, right? Set of flag register, as like that in C in 8085 we are having now that auxiliary carry, right? So like we are having now here also carry, sign, 0, then auxiliary carry, and then parity. Like we are having now the set of flags are there in that 8086 also, right? This operand is here we are getting now the result, and result is going to be placed in temporary operand, and then it will move to wherever the register we are having now, right? So this is execution unit. In that execution is unit is separate from the bus interface unit. Bus interface unit is used for addressing and address. We are having address processing through this as like accumulator, where we are having now then segment value and multiplied by 10, and then we added with that offset, we are creating effective address of the 20 bit. So here we are getting now the 16 bit data. The 16 bit data multiplied by 10, and we are adding that offset, then we are getting now, right? So this is one data. Then this data is multiplied, this data is segment data. Then we are having this offset data. Then segment data is multiplied by 10. Then offset data is added with this multiplied by the 10 result, and we are getting now the effective address. Through the effective address we can access the memory. So this is the basic of 8086 architecture. From that one we are going to study much more affected of instruction sets. Then from the instruction set, what are the instruction can be executed. Then if you see all instruction set, then we can go through that how that instruction set is going to be executed within that processor. Then we can get clear idea about that all instruction set. Then we can easily write a program. So you have to be thorough with that architecture. So in your mind you should have the total architecture. Then you should know that if you are having this instruction, how it will flow, then what will be the effective result, what the flag registers changes. Like you have to know that one, then we can easily understand the processor, say 8086 processor, and we can do whatever you want. Okay, we can stop here, then we can continue by the next lecture.